Hello and welcome to the second installment of the Getting Started Notebooks series. And in the first one, we showed how we can create a graph from a website in less than 5 minutes. And now I want to show you how we can actually use that graph to create dynamic internal links. That is that we're going to create link groups for every web page that we have in the knowledge graph. We're going to create uh, links to 10 similar web pages. And for that, I created another notebook. It's always here in the WordLift Getting Started notebook project. It's a Jupyter notebook. You can run it locally or on Google Colab. So let's open it in Colab. As usual, to open it from the Colab, we can do Colab here and replace this part with GitHub. I will send links also in the video description. Okay, so this is our Colab here. Before we start, there is a configuration here. In the secrets, we want to create the WordLift key secret, and we can just see here that it's going to look for this one. So I'm gonna enable this one, and we're set to go. So what are internal links? Internal links are hyperlinks that connect one page of a website to another page on the same domain. So this facilitates user navigation and also increases the ranking for those pages that connect together. And there is consistency between the source page and the destination pages. The way it works is that we are going to rely on the information that we have in the graph, which is both properties and facets and embedding vectors to find the best similar pages that connect to one page. And then we can query this information by using GraphQL and soon a dedicated API for the link groups and have a widget or the page itself, server-side rendering or client-side rendering, render these links in the source web page. We are using the SEO ontology to define these link groups so that basically once this is done, I can just run this GraphQL query on the graph. And for a specific URL in the graph, I can get the link group. So it's a group of links. Each link group has an identifier because I can have more than one link group in my web page. I can have one for the footer. I can have one for, I don't know, after the product description or after the list of products. I can have one for the header and so forth. So each one has an identifier. Then I have a name. It could be also represented as the name of the link group, like a heading or something. And then we can have multiple links. For every link has a position, an anchor text, an anchor value, and we can also have an anchor resource, which means it links to an entity of type web page in the graph so that they can grab additional information like abstract, keywords, date published, and author, for example. And these information are also useful to display on the web page. This is an example of how I run the GraphQL query, nothing fancy here. And this is an example response, right? So we have the web page ID and the related link group, and this is the identifier for this link group. And here we can see an example of a link. So this is the how I will query the graph afterwards to get the data. But now, how do I create this data? I just run this notebook. So this is the configuration part for the notebook. So it grabs the WordLift key. If you run the notebook locally on your computer or on other similar environments, you can put the configuration in a default py file in the config folder. Or otherwise, if we are in the Colab environment, we can get the WordLift key from the secret, like I showed before. There are very few dependencies. We use TQDM to show a progress bar, and the WordLift SDK provides high-level functions so that the code is neat. Very few imports here, and we just configure access to the API WordLift IO. And so this is the main code. As you can see, it's very, very small. And how does it work? So it works that, first of all, we get a data frame, a pandas data frame from the graph of all the web pages for which we have embedding vectors that are required to perform similarity search. And then I create an internal link handler to which I pass the API configuration and the ID of the link group. Optionally, I can also provide here a filter for the query that's going to generate internal links, because I can further customize it and tailor it so that I can, for example, do pre-filtering on specific properties. So, for example, if I have a clothing store, before running the similarity, I would probably want to add some filters so that I can run the similarity in the same department. So if I am in the women department, I want links that are part of the women department. If I'm in the men department, I want to filter by that same department in kids and so forth. Or I can do, for example, horizontal filtering based on brands and so forth. Whatever it's going to create more value in my internal links. In this case, I don't put any filter, so we're going to have just similarity. But in a future episode, I will show how I can use filters, for example, to require at least a match of one or two keywords for the for identifying the internal links. So it can be a little bit, so that the links are a little bit more consistent, but so far so good. So here the handler is called. I will try to run a couple of threads simultaneously, depending also on the machine that's going to run this notebook. And that's it. Basically, this does everything. It will calculate the internal links and it will write them in the graph. And so now we will run it. So let's run the first part. So this defines the login configuration and the configures the WordLift key. Lovely. I will run the imports and the installation of the dependencies. As you can see here, I usually put this thing here because if you run it locally, I manage the project with Poetry, so it's not necessary to run the pip install. There we go. Now we run the imports, and we will create the configuration here. The configuration only requires the WordLift key. Perfect. And now we can run the main function. So it has found 330 web pages with embedding vectors in the graph. And now it's calculating the internal links for each one of them, and it's writing them in the graph. That's great. This is the list of web pages that now have internal links. And the next step is to query the internal links using the GraphQL endpoint. And then the results can be used with any widget or server-side method to render those links. Okay, so how this is the GraphQL query that we saw in the notebook. So in this GraphQL query, I take a parameter, which is the URL, and then I will get all the entities that map on that URL. So get the web page that has that URL. And then I will get the link groups that are defined in the SEO vocabulary has link group property. And for each link group, I will get the identifier. In this case, I'm looking for the getting started one, and the name, which can be the heading of the link group, and the list of links. And when I run this query, this is the result. So we can see here, maybe I can switch to this visualization if it's going to be easier to understand. So here I have the list of entities. This is the web page. I can also print the URL. Okay, so this is the web page with this URL. And these are the link groups. There's only one link group that I created with the notebook. And here is the identifier that I created before. This is the title of the link group. And then it has 9 links. And for each link, I have a position, so I can sort them appropriately, the anchor text and the anchor value. And then I can also see the anchor resource, which is the entity of the web page in the graph that I can use to retrieve additional data, like the abstract, if I want to use it, and the list of keywords. The list of keywords is also interesting, for example, for me to build faceted widgets, which I will show quickly how it's displayed on our website. And this is what it looks like on our website. So this is the SEO data quality web page, and at the end we have the faceted widget. Here it is. So we can see the heading, and this is the list of keywords that I will use as a faceted buttons. So I can click to tailor and filter the related articles, and here got the internal links. In the next episode, I will show how to use the link group API and how to use the widget to as a drop-in web component into the web page to connect to the link group API and populate the widget with data. Goodbye.